your battery yet?
There you go. There you go.
That's cool.
So far in our videos, we've covered the power grid, basics of electricity, and some other interesting circuits, but we have not discussed the actual components that we are using in these circuits. And that is why, in this final video, we will be looking at the different components that are often used in electronics and their uses and functions.
Hello. This is a power supply used in circuits, and it does what it says. It supplies power, and essentially this is a constant voltage supply, so positive, negative output, which you can connect wires to power your circuit, and there is a voltage selector to select your voltage. Another thing to note is that while this is a simpler power supply, there are certain power supplies where you can also control the maximum current so that if you try to exceed it, it will drop the voltage so you don't fry anything. And that's generally considered a lab power supply, while this is a more basic one. And these are another form of power that I'm sure you are already aware of, but they are batteries, and they essentially use an electrochemical reaction to generate voltage at the terminals of the battery. These are 9-volt batteries, so there are 6 battery cells inside them because each one's 1.5 volts. And yeah, batteries, chemical energy converted into electricity. Alright, actually I'm holding 2 components that we'd use here, actually 3 if you think about each resistor separately, but these are essentially resistors. And what they are is, I think I've already talked about resistance, and they are just a component that is there simply to provide resistance to the circuit, to drop voltage and limit current depending on the usage. You can use them to control voltage by putting multiple ones of them wired in series from a certain voltage to ground, and then at the connection between them there's a voltage in between the 2 voltages. Or you can use them to limit current by putting them in series with a LED, for example, and it will limit the maximum current so as not to fry the component. That's what a resistor is. And then also, this little thing that I have them plugged into is called a breadboard, and it basically has a bunch of holes on it that allow multiple things to be connected together when you push them in, like so. Here in my hand is a capacitor, yet another important electronic component. This is a very large capacitor. Most are not this big because they can fit like on a circuit board. But essentially the job of a capacitor is to store charge. It's similar to a battery in that respect in that it stores energy, but it does it in a different manner. While a battery stores energy in the form of chemical energy, a capacitor stores it in the form of an electric field between 2 plates, essentially. So in here, there are like 2 thin layers of foil that are wrapped all throughout it that have a certain gap between them, and they store charge. So now that we know it stores charge, another useful function of a capacitor is that it will block DC from flowing through it, but it will allow alternating current to pass through it. So it's often used as a filter to block DC and used to filter DC from an output of, for example, an amplifier. And that brings me to another component, which I don't have with me right now, but it's called an inductor, and it is essentially a coil of wire that has a certain inductance, which is in a way almost like the reverse of capacitance. I mean, it's not really, but essentially what that does is it allows DC to flow through it, but it blocks AC, so it has the reverse function in that manner. And when you combine capacitors and inductors in certain types of circuits, you can create a tuned circuit that has a certain resonant frequency, which is useful in, for example, EQs in audio. This right here is a transistor. Essentially, its function is to amplify or act as a switch. A transistor has 3 pins on it: the collector, the base, and the emitter. When a small voltage or a higher voltage is applied between the collector and the emitter, a small current flowing from the base to the emitter can control a much larger current from the collector to the emitter. This is useful as it can be used in amplifiers and can be used as an electronic switch of sorts. So an interesting thing about a transistor is that it's solid state, which means there are no moving parts, and it is also has a long lifetime unless you abuse it. One of the things that the transistor replaced was the vacuum tube, which is what was used before the time when the transistors existed. And essentially vacuum tubes do the same thing. They amplify current, or vacuum tubes work more off of voltage, but essentially they can still operate as a switch or as an amplifier. But they are much larger and wear out much easier and are more expensive and more difficult to maintain. There's a lot of negatives to them, less efficient. And all computers before the transistor operated using vacuum tubes. So if you think about some of those old computers from the 40s and 50s, like ENIAC or anything like that, they had large vacuum tubes and they broke all the time because when a tube would burn out, they'd have to fix it, and it would be horrendous to try to figure out what was broken. When transistors came around, this allowed integrated circuits to become a thing, where you have a bunch of transistors in a small chip, which is what essentially all modern CPUs and computers are based off of. So those are some of the other advantages to transistors when compared to vacuum tubes of the past. This is of course a wire, which is used to connect up multiple components in a circuit. In this case, it has alligator clips, which make them easier to connect to things instead of having to solder or use a wire nut. You can just clip things directly together, and that is the advantage of alligator clips. Right here, we have a transducer, a speaker in this case. Essentially what this is, obviously you know what it is, it makes sound, but the way it works is you put an input of AC in here, and then it will play back whatever frequency the AC is. In the case of music, it's not a specific frequency, it's a whole wide range of frequencies being played over time. But the way it works is it puts that signal through a coil of wire, which you can't see, but it's right in here, which is surrounded by a magnet. And of course, when you put current through a coil of wire, as we talked about in one of our early videos, it creates a magnetic field. And since that magnetic field is in the presence of this magnet, it moves the diaphragm of the speaker, producing sound. And of course, it's magnetic, which you can see, like so. So another electronic component that's often used in electronics would be the electric motor. In this case, we have a window fan, or a box fan, or whatever. But in this case, it's an induction motor, an AC induction motor, which works similarly to a speaker in the sense that it's a magnetic field being produced by a coil of wire in the presence of more magnets. But in this case, it's arranged differently to produce a spinning motion. Now, a DC motor has a contact where it's only on half the time, so that it doesn't just stop like a compass would. So it essentially, the magnetism pushes it halfway, and then the inertia keeps it going, and then it turns back on, keeps it going. That's the way a DC motor works, and that's why it has to only be on half the time. But with an AC motor, it can essentially have the electronic circuit on all the time because it uses the spinning field of the alternating current to keep it going. That's why it's called an induction motor. So as you can see, I plug it in, and you hear it turn on, and you can see it move, and that hum that you hear is actually the frequency of the AC current that's spinning it, and it's also the rate of rotation. This right here is a digital multimeter, which is very useful as it can measure many things. For example, voltage, current, and resistance. And then certain meters can also measure things like capacitance and inductance, though those are more advanced normally. And it can do both AC and DC. So for example, I'm going to show you a couple things it can do. First of all, this is a non-contact voltage tester, so it can actually detect electricity presence just by putting it near a voltage source. So for example, when I put it near an outlet, it does that. Also, you can measure the specific voltage, making sure it's on volts AC, by putting the terminals right into an outlet. And you'll see this outlet is 119 volts AC. And that is some different uses of the multimeter. And if I walk over this way, we can see some other features of it. If I set it to volts DC, I can measure the voltage of a battery. So this should be about 9 volts. It's probably going to be lower because it's old. Yep, so it's 8.25 volts because it's an old 9-volt battery. Yet another thing we can do is we can measure resistance with it. So if we go to ohms resistance, we can now measure these resistors' resistance. And you will see if I actually make a good contact, it register the resistance of the resistors. So multiple uses for these things. Okay, I'm now standing with my hand on a Van de Graaff generator, and if I was a girl, I'd probably have my hair going up crazy right now. But essentially, I'm charging my body with static electricity. So if I take my hand off this ball and then touch ground, I get a huge shock. So yeah, Van de Graaff generator. Here I am holding a very large component. Okay.
Yeah, no.
Okay. This is, of course, a wire, which...
What is that?
In this case, it is an alligator clip connectors on it. It is an no.
Correspondent for how's it going? So what subject are we talking? The power grid. So what about it? Did it collapse or?
No, we're just creating an introduction.
Okay,
That's all right. And they're part of what's called the distribution grid. And yeah, that pretty bad too.
Well, can you add something else we can cut pieces together?